Welcome back, everybody. Today we're gonna talk about the Chapter 9 Descriptive Geometry. And if you look at the definition here, the descriptive geometry is defined as graphically show solution to problem dealing with points, lines, and planes and their relationship in space. Where we're gonna use it, we use it to give true size and the shape. Our point is to get the true size and the shapes. So here are the steps that we're going to have to follow to get the true size and the shape of a surface. And if you look at the first step, we're going to get the true, find out where the true length is. And then we're going to create the point view of the true length line. And then we're going to create the edge view of the surface. And then we can finish up with a true shape and the size of the object. In order to find the edge view of the plane, we must locate a true length line first in that plane, and then a point view of the true length line must be projected, which yield the edge view of the plane. By projective means, it would be impossible to find the edge view of an oblique surface from normal view without performing step 1 and 2. Solving descriptive geometry problem, you're going to have to find out the true length of the line, and as you can see, and you're going to find out where the true length of the line, and always when you have the right side view and the front view, and this auxiliary view would be your true length of the line. And then you're going to have to find the point view of the true length line, where the point view is, and then find the edge view once you have the point, and then you can find the edge view of the surface, and then you can find out the true shape of the surface. This is just an introduction to the descriptive geometry, but we're going to go into detail when I get to a little bit more into this chapter. And if you look at some of this good example here, and we have the way we're gonna make a notation of the descriptive geometry would be with a point in space, use a lowercase letter. We always use a lowercase letter unless it's like the front view or the right side view. For a triangle, you would call ABC, ABC with small case. For a line, you would just say A dash B. For the point in the space, you would call A, B, C, D. For the notation about the front view and the top view, you would use capital letter. So all the uppercase letter, F, T, R, left side view, auxiliary view, same as auxiliary view, different successive projection. And this is one of the example of notation. Or the top front view, front right side view, auxiliary view, and the right side view. All this has to be uppercase, and everything else should be lowercase. Fold line. What is a fold line? Fold line is a line that give you you can fold it into whatever the distance you want it, and then and then you can project this through the flow line to get whatever the true length or the auxiliary view. So the fold line represented by a thin black line similar to a phantom line. This is the phantom line, and then you label with the uppercase letter. It's a top view, front view, or the right side view. So spatial, the positioning of a line AB. Let's say for this example, we have point A to B. In order to show where the point this line is, you would start with the top view, front view, and your right side view. So your top view, you're gonna label them as AT, excuse me, and then to BT, and then when you get to the front view, you're gonna project this down. You call it still be the A point, but then you know this point here is A at the front point, B at the front view. So this R is your A at your right side view, B at your right side view. And once you have all this view established, you can just go to next step to make sure that the distance here and always equal to that distance here. So y equal to that y, x equal to that x. And points to remember about the descriptive geometry. We're going to label fold lines first. Keep the distance from the image to the fold line the same in all view. All measurements are taken along projection line and measure from the fold line to the point in space. Always keep a view between all measurements. So let's look at this first exercise about how to locate a point in the space. To locate a point in the space, let's say given the top view, front view, and the right side view, given this two lines here. Now to establish the point in the space, you would from here project them all the way to the top. Same thing from the point B, project them to the top view, and then you're gonna measure the distance y. This distance y has to be equal to that distance y, then the x equal to that x, and then you can just connect these two dots. And then to locate the point in the space, and so you would draw a line through and draw a horizontal line to the right side view, and then your distance here, x, is equal to this distance x here, and now the point is established. And I'm gonna end this video here, and we're gonna continue on with video 2 to talk about the points and the line.